So in our previous day's class, I have dealt some theory related to C frame of reference. And accordingly, I have solved this question. It's a very famous question. It is in even Irido also, actually. Right. Now try to please see this question. It is a simple question. You know this question. By the way, everyone go through that question. Example 14. Straw of mass M and length L is lying on a smooth horizontal surface. Small insect of mass M is sitting at the end of A of the straw. The insect crawls to the other end B of the straw. Will the straw move? This is as same as this is as same as what happens in that case? We have already displacement of the plank is equal to minus small m by small m plus capital M times displacement of the man with respect to plank. So in this case, this is nothing but minus small m by capital M plus small m times L. Negative sign indicates leftwards. So the straw moves leftwards. Right. So any doubt in this? Right. Now we will work on this question now. Already we have done n number of models on this. Okay. Now work on this, everyone. Should get answer as to or for this. Try, everyone try this. A sphere of mass. Go through this. Yeah, capital M and radius R is held on the inner wall of the hollow sphere of mass 4m. Sphere of mass M and radius R is held on the inner wall. Now, but try to please understand the center to center distance. Undoubtedly, this is of radius R. See, what is the center to center distance? Can someone please explain what is this center to center distance? Total is 12 R diameter. Sorry, yes or no? Total is 12 R diameter. Out of which how much you need to subtract? 2 R. Why? Because this is R radius and this part is also R radius. This is 10 R. It is according to me, I see this as same as man and plank question. It is like a man and plank question. So in this man is here and the plank is of length 10 R. Plank is of mass 4m and man is of mass capital M. So what do you want? The displacement part. So therefore the displacement of what do you want? Halosphere. The displacement of the halosphere is minus m by m plus 4m times displacement of the solid sphere with respect to halosphere minus m by 5m times 10r minus 2r. So it will experience a leftward force, leftwards displacement by an amount. How much? Right. Why you are late? You should have started a bit earlier. Next question. Go through the next question. It's done already. It's already done. Right. We'll move on to the next. Is it clear? Anything else you wish? I don't see any difference between this question and the above one. Only problem is same situation is happening in the examination also. The problem is you people are not identifying that they are same questions. That's the problem with you. I'm telling you again, this is the last week. If this week you do not perform, I don't expect classes properly because I think whatever the teacher is available is sufficient for you to manage the classes. See this question. Uniform rope of length L is placed over a smooth pulley. Actually, there is no roughness here. A smooth pulley and held in the position where 40% of its length lies on one side and the remaining 60% hangs on the other side. Now the rope is released from this position. Right. See, what is the length of the rope? Length of rope. Okay. What is the length of the rope? In which left hand side. Length of the rope, left side. Is you said 40%, yes. 40 by 100. 2 by 5. 2 by 5 parts of the total length. Length of rope, right side. This will be 3 by 5 L. Right. It is like two blocks, left hand side, right hand side. Right. Now, what is the expression for acceleration? Acceleration, you know, general formula is m2 minus m1 by m2 plus m1 times g. Area mass is proportional to the length. You can consider like that. So this you can take it as 3 minus 2 by 3 plus 2 times g. This will become g by 5. G by 5. In this case, it is downwards. In this case, it is upwards. Done. Right. Now the question is, what do you want? Find the vertical acceleration of center of mass of the rope immediately after the system is released. See, immediately after releasing the system is what you want, right? Chalo. Now, if I draw the free body diagram of this properly, this is the pulley. And you have the rope here, another rope here. Assume like that. Right. Fans, this sounds. Right. Now the question is, now you have the center of mass is located at area totally. The center of mass from this point is located at a distance L by 5. This is totally 3L by 5. The center of mass is located at how much distance? 3L by 10. Correct. That is the location of the center of mass. Find the vertical acceleration of center of mass of the rope immediately after it is released. Right. You want the acceleration of the center of mass. Right. So what is going to be the acceleration of center of mass? I think acceleration of center of mass is again the same. Yes or no? No. Otherwise, acceleration of center of mass is take upward direction as positive. So we will take this mass as 2 units. We will account, trust me, we will account this as 2 units of mass, we will account this as some 3 units of mass. 2m times g by 5 minus 3m times g by 5 by 5m. What you will write here? Minus g by 25. You will write that as minus g by 25. ఎందుకు ప్లస్ 5? అందుకే కదా ఇది ప్లస్ చేసా ఇది మైనస్ చేసా. ఇది ప్లస్ చేసా ఇది మైనస్ చేసా కదా అందుకే. ఎస్ ఆర్ నో? సో దిస్ ఈస్ minus g by 25 meter per second square. That is the find the vertical acceleration of center of mass of the rope immediately after it is released. Right. Next question. You find out the next question. Find the vertical velocity of the center of mass at the instant end A is L by 4 about its initial value. ఇప్పుడు మీరేం చేయాలంటే this is the configuration 1. This is configuration 1. Right. This is configuration 2, which means right. Now see, at this point of time, where lies the center of mass of the system? Where lies the center of mass of the system? So for example, we will take upward direction as positive. Okay. So what are the I said previously the mass of this is 2m because proportional to length. So therefore this is minus 2m times L by 5 minus 3m times m1 y1 plus m2 y2 by m1 plus m2 3L by 10 divided by 5m. So now what is happening here? Minus 2L by 5 minus 9L by 10 divided by 5. Minus 10 minus 9 minus 19. 5 కాదు ఒక్క నిమిషం 4 5 minus 13 అది అంతే కదా minus 13 by 50. That is the initial location of the center of mass. Again you take YCM. At this point of time, where is YCM? See, try to please understand. Now the center of mass is here. Now the center of mass is here. Now the center of mass is at a distance half of this. Now the center of mass is at a distance 2L by 5. Again, proportional to mass. Now this is m units of mass, 4m units of mass. Yes or no? Now the question is minus m times L by 10 minus 4m times 2L by 10. Okay? 2L by 10 है half of this 2L by 5, right? 2L by 5 whole by how much? 5 m cancel, minus L by 10, minus 8L by 10. It is minus 16L by 10 otherwise. Totally minus 17 by 50L. Agreed? So now you can notice that the center of mass has shifted down. So there is a loss in potential energy of the system. So therefore, what is the loss in potential energy of the system? Now from these observations, lambda stands for mass per unit length. Okay. So loss in potential energy is gain in kinetic energy. Agreed? Followed? Right. So therefore, a total length is L. So this is a half lambda L V square. Loss in potential energy, lambda L M G. Displacement area, this is 13 by 50, that is 17 by 50. The difference is how much? 4 by 50. 4 by 50L. This can be written as a 2 by 25L. Okay, no issues. Lambda L cancel, lambda L cancel. So finally, the velocity of center of mass of the system. No. This is the velocity of the rope, not the velocity of center of mass. This is the velocity of the rope. The velocity of the rope is 2 by 25 kada. Under velocity of the rope is under root G times 4 by 25 L. So this can be written as 2 by 5 times root GL. Any doubts? That is the velocity of the rope, not the center of mass. Okay, at that instant, velocity of center of mass again is equal to, bolo bhai, what is the mass of this part? M units. And its velocity is upwards, V. And this is totally 4 units of mass, 4 mv divided by 5m. Agreed? So totally this is minus 3 by 5v. Minus 3 by 5 times 2 by 5 root GL. This you will write it as 6 by minus 6 by 25 root GL. इसका मतलब है velocity of center of mass is 6 by 25 root GL downwards. Tell me, do you have any doubt in this? Any step? I'm again telling you, in case any such a model repeats and you fail in the exam, I will not swear. Because point wise, I have given a detailed information in this. It is all yours. Can ask me still. Do you have any doubt? Any level? అవును, ఒక్క నిమిషం. అసలు సెంటర్ ఆఫ్ మాస్ తీసుకోవట్లేదు నేను ఇక్కడ. టోటల్ మాస్ ఆఫ్ ద కాదు. వాట్ ఈస్ ద టోటల్ మాస్ ఆఫ్ ద సిస్టమ్? లాంబ్డా. Every link will have the same speed కదా. Whatever you lost the energy, in what form it appears? The total kinetic energy of the system. The total kinetic energy of the system. But that is not the velocity of center of mass. Because it is a distributed mass. Some is moving upwards, some is moving downwards. So all are moving in the same direction. In that case, I would have definitely informed you, yes, that is the velocity of center of mass. A portion of the system is moving upwards and the remaining portion is moving downwards. So therefore, velocity of center of mass is not same as the speed which is the entire string is moving. I think you got my point. Even when the chain is distributed equally left half and right half, at that instant it has some velocity v. Left is moving up, right is moving down with v. In that case, velocity of center of mass is 0. పొటెన్షియల్ అవును మరి పొటెన్షియల్ ఎనర్జీ అంటే ఎలా తీసుకుంటారు? ఓన్లీ ఫర్ పొటెన్షియల్ ఎనర్జీ పర్పస్ ఐ టుక్ సెంటర్ ఆఫ్ మాస్. గట్ ద పాయింట్? రైట్. This is another question. Right. Read the question carefully. No, as per your doubt, this is configuration 2. See, very simple, girl. In this configuration, where is the location of the center of mass? Here is the location of the, which means this situation is same as something which is at a distance of 13L by 50 and a mass of 5 m. Whereas in this case, 5 m, 17L by 50. Now you see what is that in this configuration, the entire mass 5m is located at 13L by 50. The entire mass 5m is located at 17L by 50, which means you can see that there is a displacement of the total mass by what amount? 2L by 25. Potential energy is lost. And how you are accounting that loss? Gaining kinetic energy. Got the point? Right. We have done n number of. Right. What is your doubt, Tejaswini? ఎక్కడ పెడుతున్నా ఇక్కడ ఏం చూసాను ఇప్పుడు ఇది y ఈజ్ ఈక్వల్ టు 0. దిస్ ఐ టుక్ యాజ్ ఆరిజిన్. ఎనీథింగ్ డైరెక్టెడ్ అప్ ఈస్ పాజిటివ్, ఎనీథింగ్ డైరెక్టెడ్ డౌన్ ఈస్ నెగటివ్. దట్స్ వాట్ ఐఎమ్ టేకింగ్. క్లియర్? తేజస్విని అడుగు, ఇంకా ఏమన్నా ఉంటే. ఏదో అనుమానం ఉంది ఇంకా నీకు? y ఈజ్ ఈక్వల్ టు 0 అని ఎందుకు తీసుకోవాలి? ఇప్పుడు ఫ్లోర్ విను విను ఫ్లోర్ మీద ప్రాబ్లం అయితే నువ్వేం చేసేదానివి? హియర్ యూ హ్యావ్ ఎ బ్లాక్ అండ్ లేటర్ ఆన్ ద బ్లాక్ ఈజ్ హియర్. అప్పుడు నువ్వేం చేస్తున్నావు? ఇది y ఈజ్ ఈక్వల్ టు 0, ఇది వచ్చేసి y ఈజ్ ఈక్వల్ టు h, అండ్ దేర్ ఫార్ గెయిన్ ఇన్ పొటెన్షియల్ ఎనర్జీ వచ్చేసి ప్లస్ mgh అని రాస్తాను. ఇప్పుడు ఈ లెవెల్ కన్నా కిందకి వెళ్ళిపోతే అదేగా నేను చేసింది. You require some reference kada to define potential. Got the point? So I am taking this line as the reference. 0 potential energy line. Anything above is positive, anything below is negative. Right. Reference only, no issues. Yeah. What about example 28? We know jumping blocks. We have done already this case, but still it is a revision question for us again. The blocks are held in position by a light thread with the spring compressed by x0 when the thread is burnt. Smallest value of x0 for which the lower block will bounce up. Already you know how to handle this situation because we have done this question as it is. Even though we have done this question as it is, but still I'll just brush up once. See, this is the initial compression. Here is your spring. This is the relaxed length. And this is x0. x0 is the initial compression. Now what is happening thereafter is that the block remains as it is on the ground. and it is stretched by an amount of y. Stretched by an amount of y. So this is ky stretching. This is also ky stretching. This is mg. You want normal reaction 0. Ky is equal to mg. So once y becomes mg by k, okay, contact is lost. అదే కదా మీరు అడిగింది lower block will bounce up. Condition for lower block to lose contact. Right. Now the question is, at this point of time, what you will normally do is you will do law of conservation of energy. You will compare these two cases. So what are the two cases? No, initial for question 1, what I am doing is, just what is the total energy? Half k x naught square is the total energy initially. What is the total energy finally? Half k y square plus mg x naught plus y. And already we know what is y. So half k x naught square is half k y square means mg square by k square plus mg times x naught plus mg by k. So by proper solving everything, you will get one condition. What is that condition? You will get a quadratic condition here, and by virtue of which you will get. Actually, we have done this question. I think you need to remember it's a quadratic condition for you. After solving, we have done this. Just refer some last week. No, last week, na? No. Energy springs before last week. We have done this. We will get x naught as 3mg by k. That is the first part which is not related to this chapter. Now, what is the second part? The height to which center of mass will rise if x naught is equal to 7mg by k. The problem here is you have 3mg by k, it will come to rest. The upper block will come to rest at the instant. At this case, upper block will come to rest. Will come to rest at the instant when lower block lose contact with the floor. That is the case. Now we are moving to this is the first case. Now we are moving to the second case. For this purpose, we will change the color of our operation. In this case, what happens? Here, if x naught is equal to 7mg by k, which is greater than 3mg by k, then what happens? Tell me. What happens is that the upper block will attain some velocity the time when the lower block loses contact, which means straight away I'm taking the case as at this instant This will have some V1 velocity, and it is just, contact is just lost when, when this is mg by k. At that time, of course, spring is elongated. From here, you should start. From here, you should start. Now, the question is, what do you want? From here, what is happening is, you need to find that V1. So, you need to compare the two cases. Apply law of conservation of energy. Half k x naught square is equal to half k y square plus mg x naught plus y plus half m v1 square. Half k x naught square 49 mg square by k square is half k y square. What is y square? Y square mg square by k square plus, you know, x naught 7 mg by k plus mg by k 8 mg by k plus half m v1 square. Right. So now the question is, now you just modify this properly. You have 49 by 2, 49 by 2 minus, where this is mg square by 2. See, hold on, I'll just explain. I'll take the term mg square by k common now. Now what I'm going to get, 49 by 2 minus 1 by 2 minus 8 is half m v1 square. Hold on, don't get confused. 48 by 2. 48 by 2 means 20. 24. 24 minus 8. 16. So therefore, mg square times 16 by k is half m v1 square. Now with this, you will get the value of v1. Okay. So what is v1 in this? V1 is under root 32. Under root under root 32 times m g square by k. That is velocity. What is that? Now it is in air. Now entire system is in air. Now the only force acting on the system is the weight. So what is the velocity of center of mass of the system now? M V1 plus M into 0 divided by 2M. So therefore, you will get velocity of, let us call this as V1. So you will get V1 by 2. What is your question? Don't forget. The height to which center of mass of the system will rise. Okay. Now, hold on. At this instant, where lies the location of the center of mass? YCM is, okay, do the string and x naught తెలుసు y తెలుసు మీకు ఇప్పుడు. అరే x naught తెలుసు y తెలుసు మీకు. అరే ఒక్క నిమిషం. We need to take something as a reference kada. For example, if I am taking the relaxed length of the spring as L0, for example, where lies the location of center of mass? Tell me. M L naught plus mg by k plus m into 0 by 2m. This is nothing but L naught by 2 plus mg by 2k. That is the initial location of the center of mass. Okay. Now the question is, what is the maximum displacement of the center of mass? Actually, that is the intention, I think. That height to which center of mass system will rise, not the location of the center of mass, what they are asking. No issues. Now this is as if like a point mass projected vertically up with this velocity. So what is the expression for H max? You can treat as if like it is the center of mass which is projected up with velocity VCM. So it goes to some maximum height H given by H is equal to VCM square by 2G. Right. So therefore, what is that I can give you there is H is VCM square, V1 square by 8G. What is V1 square? 32 mg square by 8gk. 8 fours are 32 g. So finally 4 mg by k. Okay. But the problem is they are asking from the initial stage. Initially, where is your system? Hold on. Initially, where is your system? No, they're asking from the compression stage. Initially, your system is 1 minute. I have just a small mistake here. I'll correct it right now. No issues. What is the initial system? Can you please tell me? 7 mg by k compression. So, the block is here initially. So now what is the location of the block? YCM initially. Where is YCM initially? Where is YCM initially? See, I should write this as m times L naught minus 7 mg by k plus m into 0 by 2m. So this is going to be m cancel అయిపోయి L naught by 2 minus 7 by 2 mg by k. That is the initial at the time of release. The height to which the center of mass will rise if x naught is equal to 7 mg by k. ఇప్పుడు మీరు వేసిన h ఎక్కడి నుంచి లెక్క తీసుకోవాలి? From where I need to consider the calculation of h? Hold on, I'll just show you here. The problem what I will face is, మీకేమో ఈ ప్రాబ్లమ్స్ కష్టం, ఇవే వస్తాయి వ్యాట్లో, మీకు సబ్స్టిట్యూషన్ టైప్ ప్రాబ్లమ్స్ కావాలి, నేను చెప్పలేను అది. Right. This is the compressed stage, initial compression stage. This is the natural length of the spring. From this state to which state you are moving? Right. From this stage to this stage to when somewhere is you have the center of mass. Now your center of mass is here. Somewhere you have the center of mass here. From this stage, you have identified that the rise is 4 mg by k. Very simple. Remember, from this stage to this stage, it is actually 8 mg by k. Yes or no? Half of this will be the raise during this process. Why? Because one mass is all the time at rest. From this stage to this stage, this block displaced by 8 mg by k. So center of mass will displace by 4 mg by k. And from hereafter, how much is it is displaced? You have an idea, 4 mg by k. So what is the total displacement, total rise? 8 mg by k. Doubt cleared or not? Tejaswini, Pakka, sure. Next question. Any doubts further? Right. Good application actually. Some questions were repeated actually. I have noticed it. We will manage it, no issues. Read the question carefully. You have two thin rods of identical material and equal cross sections are connected at A by a frictionless joint. Lengths of the two rods are AB given, AC given. The structure is kept vertical. It is released from position, and the ends B and C, slide so that the angle between the two rods decreases. The angle between, what is that? Angle between the two rods decreases. Where will the joint A hit the table? Assume that all structures always remains vertical during the fall. No, one should understand there is no horizontal force in this. Please try to understand. This is the center of mass location for AB. And this is the center of mass location for AC. Let this be at this point, let you have some mass M1. At this point, you have, of course, mass is proportional to length here because uniform, right? So now what is going to happen? There is center of mass. I think M2 is high. Center of mass will be closer towards heavier mass. So here lies the center of mass. So practically speaking, what's the deal? Practically speaking, since there is no horizontal force, the center of mass should not undergo any leftward or rightward displacement. I am repeating again, since there is externally, don't say the left rod is pushing right rod rightwards, right rod is pushing left rod leftwards. See, they are internal forces. Externally, do you see any force acting on this system? Since there is no external force acting on this system in horizontal direction, location or x coordinate center of mass remains unchanged. That is it. Any doubts, boys and girls? Okay. Now, the question is, Where will the joint A hit the table? Assume that the structure always remains. No. This is the situation. Finally, for example, when it falls, what happens? That will change the color. Let us change the color. Suppose after falling, I am assuming the A leftward పడిందని తీసుకోవాలా ఎలా తీసుకోవాలి సో దట్ ద యాంగిల్ ఈజ్ డిక్రీజింగ్ కదా ఈ యాంగిల్ తగ్గుతుంది సో ఆఫ్టర్ ఫాలింగ్ రైట్ ఇది ఏంటో తెలుసా ఫర్ ఎగ్జాంపుల్ బిఏ అనుకోండి ఓకే కలర్ చేంజ్ చేద్దాం దట్స్ అది ఐ am assuming it like this మళ్ళా మనం స్టైల్ right so now this may be some A dash and this end may be some C dash but still the center of mass is here only agreed now I am writing certain terms mass of rod America రెండు పేర్లు ఉన్నాయి కాబట్టి we will call this as AB this is nothing but lambda L1 similarly mass of rod AC is lambda L2 agreed till this point agreed that is the data that's all now AB can be replaced with a point mass which I have shown here that lies at that bro AB కానీ AC కానీ I have just represented now నాకు కావాల్సిందల్లా ఏంటంటే in that case what is BD I want this distance assume that I am projecting here BD what is BD I want BD here what is BC first of all agreed now now tell me I am assuming this this end shifted by some x a or the center of mass location this particular point shifted by x I'm assuming like that I just want BD distance. How do I know BD? Are very simple. Half rods. And that see. Are boss. It is as same as L1 by 2, L2 by 2. Midpoint se kada na ibi. So kabatti BD will become half BC. BD becomes half BC. Okay, right. Now we will take some P as our origin. Let us consider space అయిపోతుంది నాకు. Consider P as our origin. Origin means x is equal to 0 of the coordinate system. Right. Now, what is the x coordinate of center of mass? What is the x coordinate of center of mass? So xcm is simply at that instant, at this instant, m1 into 0 plus m2 times bd divided by m1 plus m2. So I'll use only bd till certain point because I don't find any fun in L2 by L1 plus L2 times BD. Is this okay? This is the initial location of center of mass. Since there is no external force acting on this system, in our x coordinate center of mass remains unchanged. That's my logic actually. That is my logic. Right. Okay. Next, what else? What else we have? When the structure collapses, color change. When structure collapses, okay, when this structure collapses, what is happening? The x coordinate of the center of mass, that's what I told, is still L2 by L1 plus L2 times BC by 2. Agreed? Right. ఇక్కడ దాకా బాగానే చేశారు. Still, okay, but let end A displace by some x. Agreed? No. What happens? Because of this, what happens? End A displaces by x. Because of this, what happens? M1 is a point mass still. How far is M1 from A? Can you please tell me? In fact, you said that this distance L1 by 2. దీనికి ఒక మైరం చేస్తాను. L1 by 2. ఇప్పుడు end A is from center of mass x, from end B it is x కదా. అప్పుడు ఇక్కడి నుంచి ఇది ఎంత కావాలి? L1 by 2 minus x. So the new x1. ఏంటి అలా చూస్తారు నా ఇంకా బి ఆరిజిన్ అని తీసుకున్నారు. కరెక్టే కదా? ఓకే. బి నుంచి ఎండ్ ఏ ఎక్స్ డిస్టెన్స్ లో ఉంటే ఏ ఎండ్ నుంచి సెంటర్ ఆఫ్ మాస్ ఎంత డిస్టెన్స్ లో ఉండాలి? సెంటర్ ఆఫ్ మాస్ ఆఫ్ ద రాడ్ ఏబి L1 by 2 డిస్టెన్స్ లో ఉండాలి. ఇది ఎక్స్ అంటే అది ఎంత ఉండాలి అప్పుడు? L1 by 2 minus x. కరెక్ట్. సో ఫస్ట్ ఆ డేటా నాకు వచ్చేసింది. నెక్స్ట్ సిమిలర్లీ ఎట్ ఏ లొకేషన్ L1/2 minus x. Similarly, end C ఇనీషియల్గా ఎంత దూరంలో ఉంది? End C initially is at location BC before collapsing. Okay. After collapsing, what is the location of that? Same, L2/2 minus x. L2/2 minus x. Now we will take XCM again. So what is XCM? XCM is simply L1 times L1/2 minus x plus L2 times L2/2 minus x divided by, why I am writing L1 and L2, I think you have understood already. Say lambda multiplication factor, numerator and denominator anyway gets cancelled. But remember, just because that you have changed the coordinate, center of mass won't change. It is still the same. L2 by L1 plus L2 times half BC means under root L2 square minus L1 square. So this can be written as L2/2 times under root. అరే ఇది లోపలికి తీసుకెళ్తే L1 plus L2 whole square అవుతుంది. సో అప్పుడు మీరు యూ కెన్ రైట్ ఇట్ యాజ్ L2 minus L1 by L2 plus L1. రైట్, ఇది సాల్వ్ చేస్తారు. ఇది సాల్వ్ చేస్తే యూ విల్ గెట్ సమ్ టర్మ్ ఇన్ సమ్ వాల్యూ ఇన్ టర్మ్స్ ఆఫ్ ఎక్స్. ఆర్ you will get some value in terms of x. You know what is that? I'll explain that also. L1 square by 2 minus x, L2 square by 2 minus L1x. X times L2 is L2/2 times, you take this inside. You know what happens? L2 square minus L1 square. అరే నాన్న ఇదంతా సాల్వ్ చేసుకోవాలి. సాల్వ్ చేస్తే you'll get x. You'll get x from this. Okay, you got the point? So they want only that x కదా, అంటే L1 square అరే 2 ఫస్ట్ వేసే ఇచ్చాము అసలు. అగనండి, L1 square by 2 plus L2 square by 2 minus L2/2 times root L2 square minus L1 square is x times L1 plus L2. దీంతో you'll get x. Any doubt? What is that they're asking in the question? Where will the joint A? Yes, what is x? X is nothing but the location of, what is that? It is nothing but the location of joint A. So here x is nothing but location of joint A. Sir, example వస్తే మరి ఎలా చేయాలి? అప్పుడు చేయరు ఎలాగో మీరు. At least you need to listen kada. You need to know how to do such a difficult models. So till now, this is the difficult model which you faced. Even I think this is also a difficult model. Even this is also a difficult model. So you won't expect easy questions daily. But tell me, you have any doubt in this? Yes. ఎక్కడక్కడ ఒకసారి చెప్పు మళ్ళీ. అరే ఏ నుంచి సెంటర్ ఆఫ్ మాస్ ఎంత దూరంలో ఉంటుందిరా? మామూలుగా L2/2. ఏ లెఫ్ట్కి ఎక్స్ షిఫ్ట్ అయింది, ఏ నుంచి ఆ సెంటర్ ఆఫ్ మాస్ కూడా ఎంతేగా, అదేగా నేను రాసింది. క్లియర్ ఆర్ నాట్? నెక్స్ట్, I think this is a repetition. I think you don't require this. I've done all this repetition. Yes, this is a very good question. basically? It's a very good question, actually. Read the question carefully. Fortunately, they have given the shape as a semicircle. See, if you ask me, forget about all this chapter. If you ask me that it is a semicircle, then the center of mass is at a distance of, yesterday only I have taught you all this. Where is the location of center of mass in case of semicircle? ఏం చదవాలా నిన్న? ఏందమ్మా ఇది? నిన్న ఏం చదవాలా అయితే? ఇంకా ఆలోచిస్తున్నారంటే మీరు మనుషులు కాదు. ఏం చదవలేదు కదా నువ్వు? నిన్న ఇదేం చదివావా? మళ్ళీ చదవాలా? ఏమొస్తుంది నీకు? సబ్జెక్ట్ ఏమొస్తుంది చెప్పు. నిన్న చదివింది వచ్చిందా నీకు? నిన్ననే చెప్పాను ఇది. అంతే. ఇంగ్లీష్ పాఠం, సోషల్ పాఠం విన్నట్టుంటే ఏమొస్తాయమ్మా మీకు చదువు? 2r/π. That is the location of center of mass. Now you stretched this into a V shape. Symmetric V shape, fortunately. So the center of mass of this lies here, and the center of mass lies here, and the center of mass lies exactly at the center. Right. Now the question is, what is AC? You said, see, obviously AC plus CB is pi r. AC obviously will be pi r/2. Right. V shape. Right. Now let us assume that this is at some depth h. What అడిగింది ఏంటి? Calculate the shift in the position of center of mass of the rope. The midpoint C is pulled so that the rope acquires V shape as shown in figure. Okay. Now, one point is very clear. This distance is still r. Don't forget that. This distance is still r. And this distance is AC/2. Correct kada? Right. Now, just tell me what is the, otherwise I'll take this as h/2, I'll take this as h. Agreed? Now, h square plus r square is AC square. Agreed? H is under root AC square minus r square. Agreed? AC square is nothing but pi square by 4 r square minus r square. Agreed? So this is nothing but r times r/2 times pi square minus 4. h/2 is what you want. r/4 times pi square minus 4. Now try to please understand, initial position of the center of mass is 2r/π. Final position of the center of mass is h by 2 from the same reference. Hello, from the same reference I am working, which is nothing but r by 4 times root pi square minus 4. I just have a doubt. Take r as a separate factor. Which is higher? Let us work. Now see, if I work totally, you will get approximately this one as 0.61 r. Last year chesam kada nenu. That works around 0.61 r. And 2r by pi. 2r by pi and 2 by pi. This works around 0.64 r. ఇప్పుడు మీరు చెప్పండి, because of shifting from here to here, is the center of mass shifting up or shifting down? Up or down? Ela. So yi 0.64, yf 0.61. So in fact, y initial is greater than y final, means shift is upwards. Right. Let m stands for mass of the system. So in this case, work done by external agency is nothing but mg delta y. M into g into 0.64 minus 0.61 r. So this is nothing but m into g into 0.03 r. So in fact, by changing the structure from semicircle to this, you are doing work on the system. How I know? Because the center of mass of the system shifted up. Any doubts on this? Please ask me. If you have any doubts on this, please ask me. Are we clear? Pakka. May I proceed to the next question? Right. Do this fast, fast. 1, 2, 3, 4. Where lies the center area uniform chain of length pi r by 2 means exactly it is like an arc. It's like an arc, basically. We have done this question yesterday. Initial location of center of mass. We have done this question. For an arc, we have done. మీరేం గుర్తుపెట్టుకోరు అవి. You will get the answer as r sin theta by 2 by theta by 2. Theta ఎంత? అరే యార్ పై ఆర్ అయితే 180, పై ఆర్ బై 2 90. Sin r sin 45, 1 by root 2 divided by pi by అరే theta ఎంత రా నాన్న? 90 యాక్చువల్గా, pi by 2 యాక్చువల్గా, pi by 4. So what is this going to be is 2 root 2 r by pi. Have you agreed with this, boys and girls? Now find the speed of the chain. Its one end just touches the floor. ఏది చేసినా నా ఆన్సర్ అయితే ఇదే. See, for example, if one of the ends touches the floor, (90°), here lies the center of mass. You give me whatever the reason, I know that this distance R is still the same. Okay, na? And this is R actually. But now this makes an angle 45 degrees. What is Y final? Y final is nothing but Y initial times sine 45, which is nothing but 2R by pi. Agreed? నేను వేసాను రాసి చెప్పు మీకు ఓకేనా? So now what do you want is, that's all. You know, earlier center of mass is here at yi. Now the center of mass is here somewhere. Okay, which is yf. Okay. Now what you will do? Loss in potential energy is gain in kinetic energy. So mg delta h. ఏం రాస్తారా నాన్న మీరు? √2 - 1 times 2r by pi is half mv square. M is a. So finally v is under √4rg times √2 - 1 by pi. That is the velocity of what? The chain. What is that they are asking? మరి ఇది కాదుగా. Okay, no issues about. No, at this point of time, every point of the chain will have the same speed, means same angular velocity. Okay, R omega, velocity of center of mass is simply R omega. అంతే కదా? All the links have same omega. The center of mass is now exactly in a circular motion. So which is at a distance from the center R. R omega. R is nothing but your yi. So it is nothing but 2√2 R 2√2 by pi times R omega. R omega is this. So therefore this is 2√2 by pi times under √4rg √2 - 1 by pi. Now there is a threat. Lot of students, someone was asking me, I think you are asking me. Chain problem చేస్తాం, pulley left side, right side. You assume that is V is the velocity of the center of mass. That is not the velocity of the center of mass. It is the velocity of every link at that instant. Here also it is the velocity or speed of every link at that instant. With this I brought omega. And I have understood that at that instant center of mass is following a circular track of radius r, which is nothing but yi. R omega is the velocity of the center of mass. Lot of students will do a mistake. They will do the mistake. They will stop over here. And unfortunately, we will have one such option. Any doubts? Akka? Tejaswini? Clear? Renura? Varun? Pakka? Right. Not to. నా టార్గెట్ వరుణ్, దీని తర్వాత ఎన్నో లెక్కే ప్రాబ్లమ్స్. Evening. Yes, boys, come. Uniform bar AB of length 6A has been placed on a horizontal smooth table of width 5A. As shown in the figure. Length 2A of the bar is overhanging. Mass of the bar is 4m. An insect of mass m is sitting at the end A of the bar. The insect walks along the length of the bar to reach its other end B. Right. That's the deal. 2A. Will the bar topple when the insect reaches the end B of the bar? After the insect reaches at B, another insect of mass M lands on the, okay, Mundi age is there B1. We cannot solve the entire question in one shot, no? So that is the reason why we will do stepwise. Read the first 3 lines of the question again, everyone. Uniform bar, right? Since there is no external force, first of all, what is my observation is no external force. Remember, in horizontal direction, in X direction. Okay. What is the effect of this? Everyone, please help me. What is the effect of this? No external force in X direction. What is the X center of mass? X CM will not move. Right. That's the first point. So therefore, what I can write is, for example, let what do you want? What we want is the insect is moving. Now, first of all, just hold up. Forget about all these things. If I can do this like speed, can I do is like a man plank? Oh, okay, right. Displacement of the plank is equal to minus small m by small m plus 4m times 6a. For example, like this. So displacement of the plank is nothing but minus 6 by 5. Minus sign indicates it moves leftwards. Okay, earlier just initially end B is at 2A distance. Now it has shifted 6 by 5A leftwards. Correct or not? Yes or no? So 2A minus 6 by 5A. What is this? 4A by 5. So now 4A by 5 means the length of the hanging. What is this distance? Please tell me. Length of hanging part. Length of the hanging part. Other right side. Length of the specific mention to the right. To right side of a table. Right. Right. The problem here is, now my problem here is, I will take this as the origin. This end as the origin. This end I will take it as origin. 0. Now insect is here. And the insect insect mass is M. And it is at a distance of X is equal to 4A by 5. Clear? Next. Where lies the center of the table? Now, it will be 4A by 5 kada. Correct? ఇప్పుడు 3A minus rough calculation. 3A minus 4A by 5 enta 11A by 5. Can you please tell me what I have written? 11A by 5 represents the center of mass of the table. The center of mass of the table, plank, is at a distance of 11A by 5, where the mass is 4m. Now let me find the location of XCM. Now I am finding XCM right now. I'm taking this as X is equal to 0. So XCM is, first right side that I'm positive. M times 4A by 5 plus 4M times minus 11A by 5. Why minus 11? Because to the left side. By total mass is 5M. Can you please help me in solving this? 4 ఇది minus 44 ఇది. Minus 40 by 25A. ఇప్పుడు చెప్పండి, -40/25A అంటే ఏంటి దాని అర్థం? -40/25 అంటే 5 టేబుల్ పోతుంది. -8/5A అంటే the whole, this is the edge. And if this is the plank, and here is the insect, then here lies the center of mass of system, which is at a distance of 8/5A. Definitely the system will not topple. ఎప్పుడు టాపుల్ అవుతుంది? ఎడ్జ్కి రైట్ సైడ్ వస్తే టాపుల్ అవుతుంది. సో ఫస్ట్ ఆన్సర్ ఈస్ నో. No, it will not topple. Next, one more extension to the, till here any doubt, boys and girls? Till here any doubt? Definitely ఇది రిపీట్ అవుతుంది క్వశ్చన్ someday or other. An insect of mass M is sitting at the end of the bar. Okay. After the insect reached at B, another insect of mass M lands on the end A of the bar. Find the largest value of M which will not topple the bar. What is the question? By the way, I think we will do one mistake. From here, what is the distance? 4A by 5. What is the length of the table here? 5A. Now, can you please tell me, by the way, what is this length? What is this length? Yeah, this is totally 6A minus 4A by 5. 6A minus 4A by 5 ఎంత? 30 అంటారా? 26. దీన్ని ఇలా కూడా రాసుకోవచ్చుగా, 5A plus A by 5 అని రాసుకోవచ్చు. You know what is happening over here? I'll explain. విషయం ఏంటంటే ఇక్కడతో టేబుల్ అయిపోతుంది. Because this part is 5A and this part is A by 5. అంటే ఈ ఎండ్ A by 5 లెఫ్ట్ వర్డ్స్, ఆ ఎండ్ 4A by 5 రైట్ వర్డ్స్ ప్రొజెక్ట్ అయ్యి ఉంది. రైట్, ఇక్కడ ఇన్సెక్ట్ ఉంది. యాజ్ ఆఫ్ నౌ సెంటర్ ఆఫ్ మాస్ ఇక్కడ. వాట్ యు వాంట్? You want to place some capital M such that still the table won't topple. నాకు అర్థమైన క్వశ్చన్ నేను రాసుకుంటాను, మీకు ఎందుకబ్బా. దిస్ ఈస్ ద టేబుల్, దిస్ ఈస్ ద టేబుల్ and this is of length 5A. Now, to my understanding, that's 4A by 5. This is A by 5. Agreed? Now you have one insect here of mass M and A by 5 somewhere here. అరే ఇప్పుడు A by 5 కదా, ఫ్రమ్ హియర్ 4a/5 అది మొత్తం ఎంత ఇది 6a కదా 3a రావాలరా 3a రావాలంటే ఎంత దూరం ఉండాలి ఇక్కడ నుంచి ఎంత దూరం ఉండాలి 3a ఉండాలి ఇది సెంటర్ ఆఫ్ మాస్ ఇక్కడ మాస్ ఎంత ఉంది ఇది ఎంత ఉంది 4m మాస్ రైట్ సో ఇక్కడ నువ్వు క్యాపిటల్ ఎం పెడుతున్నావు టాపులు అయితే ఏమవుతుంది సెంటర్ ఆఫ్ మాస్ లెఫ్ట్ వర్డ్ షిఫ్ట్ అవుతుంది సో ఇది ఐ విల్ టేక్ ఇట్ యాజ్ నౌ x is equal to 0 I'll take that as x is equal to 0 if xcm is less than or equal to a/5 toppling takes place అంతేగా define now this is x is equal to 6a this is x is equal to 3a okay now I will substitute the formula capital M times 0 plus 4m times 3a plus m times 6a divided by capital M plus 5 small m is less than or equal to a/5 right అరే ఇక్కడ ఏమవుతోంది 12 plus 6 18 times ma by capital M plus 5 small m less than or equal to a/5 a cancel from this I can write 18 5s 90m less than or equal to m plus 5 small m. So m greater than or equal to 85m. If m is greater than or equal to 85m, what happens? Center of mass will shift from the left edge of the table. It will topple. So therefore, what is that you are asking? Will not topple. So if m is 85m, okay? If m is less than or equal to 85, it will not topple. This is the condition for toppling. If m is less than, so m max allowed is 85m. I'm telling you, you will get this question. Any doubt? Stage wise, I have done. Stage wise. Anika, don't feel that this is like a social studies. You study one paragraph, you study second paragraph, third paragraph. No, concept. And don't say in exam, I am forgetting half. No, I've given you full clarity on this question. Right. Next question. Are we clear on this? Yes, I think you can do this. At least 3 to 4 questions you will have from this part only. See, one thing is very clear in this question also, there is no external force in the horizontal direction. No external force in horizontal direction. So what happens is delta xcm will become 0 for this, as per the characteristics of center of mass. Now, two men are A and B are standing, the system is in both A and B interchange their positions. Can you please explain me what is exactly the meaning of that? For example, జనరలైజ్ చేద్దాం నా ఉద్దేశం అంతే Because ఒక్క నిమిషం ఆగండి. Mass of A, displacement of A plus mass of B, displacement of B plus mass of Planck, displacement of the Planck is equal to 0. See, try to please understand. Keep working on this.